Stoichiometry is relating products and reactants using moles to convert from one to another. It is another method of dimensional analysis. To understand stoichiometry, we're going to use 4 conversion factors. First is molar mass, Avogadro number, molar volume, and then last, mole ratio. Molar mass tells you that 1 mole of X is equal to its mass in grams of X. A mole measures any amount. It measures amount. And this was the SI unit in the metric system. So molar mass is a conversion factor in which it tells you that 1 mole of X, and X can be a compound, an element, an ion, and so forth, is equal to its mass in grams of that X, compound, element, or ion. We get the mass off the periodic table. So for example, if we have water, H2O, it has 2 hydrogen. Each hydrogen is 1.01 off the periodic table. Since there is 2, we need to multiply by 2. And then the mass of oxygen off the periodic table is 16 grams. If I add this, this is going to be 18.02 grams. So this tells us for water, 1 mole of water is equal to 18.02 grams of water off the periodic table. So let's look at the following example. First question asks, how many moles are there in 15 grams of lithium? We are given mass of 15 grams and we have moles. We have only one conversion factor that has moles and mass. That is molar mass. We said 1 mole of X is equal to its mass in grams X. So in this case, we have 1 mole of lithium, the element. Its mass off the periodic table is 6.94 grams of lithium. So just like before, we're going to start with what's given. What's given is 15 grams, so 15.0 grams of lithium. And this just becomes dimensional analysis. Diagonal units need to be the same. Grams of lithium, grams of lithium. The number in front of lithium is 6.94, so that goes right here, 6.94. Since this is a conversion factor, 6.94 equals to 1 mole of lithium. So on top, we get 1 mole of lithium. The grams of lithiums cancel out. So now I do my math. 15 times 1 divided by 6.84 will give you 2.16138. We need to do sig figs. Conversion factors do not count. So we look at the original problem. The number is 15.0. That last 0 is significant because there's a decimal and a significant digit in front. So there's 3 sig figs. So it's 1, 2, 3. 1 to the right. So this is 2.16 units of moles of lithium. In the second one, how many moles? Again, we're looking for moles in 238.0 grams of ammonium sulfate. So the first thing I'm going to do is I'm going to calculate the molar mass. So 1 mole of sodium sulfate is going to equal to, it has 2 nitrogens because it's 2 times 1. It has 8 hydrogens because it's 4 times 2. It's 1 sulfur and 4 oxygens. So this is going to be 2 times 14.01 grams, 8 times 1.01 grams. Sulfur is 32.07 grams, and oxygen is 4 times 16.00. If I complete my math, I'm going to get approximately 132.17 grams. So 1 mole of Ammonium sulfate equals to 132.17 grams of ammonium sulfate off the periodic table. So I'm going to start with what's given. What's given is 238.01 grams of ammonium sulfate. Again, we need to write our elements in units. Diagonal units are the same, so this has to be the same thing on the bottom in order for it to cancel out. We know the number in front of grams. We add it up to 132.17. What's left over is equal to 1 mole, so that goes on top. We're going to multiply 238 times 1 divided by 132.17, and this is going to equal to 1.80078. Again, we need to do sig figs. Conversion factors don't count. There are 5 at the beginning. The 0 here is significant because it's surrounded by significant digits. So 1, 2, 3, 4, 5. I look 1 to the right. So this becomes 1.8008 moles of ammonium sulfate. Pause the video, try the next two on your own, and then check your answer. These problems too, we are doing molar mass. We're given moles and we're going to mass. So we're doing the same problem, but we're going in the reverse direction. Again, we know that 1 mole of phosphoric acid, acids all begin with an H, charge is 1. Since there's no hydro, we know this is a polyatomic. Aches are 8, so this is phosphate, which is PO43. Crisscross, this becomes H3PO4. This is equal to its mass. It has 3 hydrogens, 1 phosphorus, and 4 oxygen. So this is going to be 3 times 1.01 gram. Phosphorus is 30.97 grams. Oxygen is 4 times 16 grams. If I add this up, this becomes exactly 98 grams. So the molar mass of 1 mole of phosphoric acid is 98 grams. So we're going to start with what's given. What's given is 0.00340 moles of phosphoric acid. And again, diagonals must cancel out, so moles of phosphoric acid. The number in front of moles is 1, so we put 1 here. This is a conversion factor. It is equal to 98 grams of sulfuric acid. 98 grams of phosphoric acid. So we're going to multiply 0.0034 moles times 98 divided by 1. This is going to equal to 0.3332. Now I need to do sig figs. Conversion factors don't count. These zeros are not significant. These are placeholders because there's decimal, no significant digit in front. This 0 is significant because there's a decimal and a significant digit in front. So here, these 3 are significant. So it's 1, 2, 3. I look 1 to the right. 0.333 grams of phosphoric acid. Next one, we're doing the same thing. We have 1 mole of arsenic, which is equal to 74.92 grams of arsenic off the periodic table. Let's start with what's given, which is 238 moles of arsenic. Diagonals need to be the same. Moles of arsenic. The number in front of moles is 1. It is equal to 74.92 grams of arsenic. The moles cancel out. So 238 times 74.92 divided by 1 gives you 17,830.96. We need to do sig figs. conversion factors do not count. There are 3 because all 3 digits are non-zero digits. So we count 1, 2, 3. I look 1 to the right. So this is 1, 7, 8. We need 2 zeros for a placeholder. The better answer is 1.78 times 10 to the 4th grams of arsenic. The second conversion factor is called Avogadro's number. Avogadro's number states that if you have 1 mole of X, any element compound, it is equal to 6.022 times 10 to the 23rd units of that element or compound. The units could be any of these. It could be molecules, atoms, ions, particles, formula units. You need to memorize this conversion factor. So here we're converting molecules to moles. Since it's molecules, we know it's Avogadro's. The units can be anything. So that means I know 1 mole of X here, which is C2H6, is going to equal to Avogadro's number, which is 6.022 times 10 to the 23rd. The units are now molecules, C2H6. So I'm going to start with what's given, which is 3.01 times 10 to the 23rd molecules of C2H6. We need to write units and we need to write this elements or compounds. Diagonal units cancel out because this is, again, dimensional analysis. They have to cancel out. The number in front of molecules is 6.022 times 10 to the 23rd, so we write that in. What is that equal to? It is equal to 1 mole, so that goes on top. So we need to multiply 3.01 times 10 to the 23rd times 1 divided by 6.022 times 10 to the 23rd. If you calculate it, you should get 0.49983 significant digits. This doesn't count, so we look at the first set of numbers. Exponents don't count, so everything in front counts as significant. So there's 3, so I go 1, 2, 3. I look 1 to the right. The 9 becomes a 0, so this becomes 0.5. But we must put 2 zeros to make it significant because there's 3 significant digits. If you just write 0.5, there's only 1. So this is moles of C2H6. How many moles are in 0.25 molecules of CH4? So again, this is Avogadro. So we have 1 mole of CH4. This is equal to Avogadro's number, 6.022 times 10 to the 23rd. And we don't write units, we write molecules of methane. We start with what's given, which is 0.25 molecules of methane. Diagonal units have to be the same to cancel out. Molecules of methane, molecules of methane. On top, so the number in front of molecules is Avogadro's number, 6.022 times 10 to the 23rd. This is equal to 1 mole of CH4. So 0.25 times 1 divided by 6.022 times 10 to the 23rd will give you 4.1514 times 10 to the negative 24. So we need to do sig figs. So if I look here, conversion factors don't count. There are 2 digits in the front, so I need 2 in my answer. 1, 2. I look 1 to the right. This becomes 4.2 times 10 to the negative 24th. We need to write the exponent, moles of CH4. So try these 2 on your own and then check your answer. So here we have formula units. Formula units tell you this is Avogadro's. So we know that 1 mole of calcium chloride must equal to Avogadro's number times 10 to the 23rd. My units here are going to be formula units of calcium chloride. So I'm going to start with what's given, which is 2.14 times 10 to the 24 moles of calcium chloride. We're going to do diagonal units. Moles of calcium chloride, moles of calcium chloride. The number in front of moles is 1. So that is equal to Avogadro's number. That goes on top. Formula units of calcium chloride. So I'm going to multiply 2.41 times 10 to the 24th times 6.022 times 10 to the 23rd. If I do that, I'm going to get 1.4513 times 10 to the 48th. So I need to do sig figs. Conversion factors don't count. Scientific notation, the exponent doesn't count. Everything in the front counts, so there's 3. 1, 2, 3. I look 1 to the right. The 5 stays, so it's 1.45 times 10 to the 48th. Formula units of calcium chloride. So how many molecules of glucose are in 1.2 times 10 to the 24th moles of glucose? Again, since it's molecules, we know it's Avogadros. So 1 mole of glucose is equal to Avogadro's number, 6.022 times 10 to the 23rd molecules. We don't write units, it's molecules here of glucose. I'm going to start with what's given. What's given is 1.2 times 10 to the 24th moles of glucose. Diagonal units have to cancel out, so moles of glucose, moles of glucose. The number in front of moles is 1. Here I have Avogadros because it's equal. Molecules of glucose. Please do not abbreviate molecules as MOL. That is the abbreviation for moles. If you write MOL for molecules, I will mark it off because that is the abbreviation for moles. So 1.2 times 10 to the 24th times Avogadro's number divided by 1 gives you 7.2264 times 10 to the 47th. Now we need to do sig figs. Conversion factors do not count. For scientific notation, exponents don't count. There's 2 because everything in the front counts, so we're going to have 2 in my answer. 1, 2, I look 1 to the right. It stays, so it's 7.2 times 10 to the 47th molecules of glucose. The third conversion factor is molar volume. Molar volume is 1 mole of X, any element or compound, is always equal to 22.4 liters of X. This only occurs at STP. STP means standard temperature, which is 0 degrees Celsius, standard pressure, which is 1 atm, which equals 760 millimeters of mercury, which is also equal to 760 torrs and 101.325 kilopascals. For this unit, everything will be at STP, so you can always use molar volume. So in this problem, we are going from liters to moles, so we know this is molar volume. All of these will be at STP. So molar volume is 1 mole of X is equal to 22.4 liters of X. Here, since it's hydrogen gas, it tells you that 1 mole of H2 is equal to 22.4 liters H2. We're going to start with what's given, which is 3 liters of H2. Again, this is a conversion factor, so it is dimensional analysis. Diagonal units have to be the same, so liters, H2. The number in front of liters is 22.4. On top, it is 1 mole because it's equal to each other. They're equivalent. The liters of H2 cancel out. We have the unit we want, which is moles of hydrogen gas. So 3 times 1 divided by 22, 0.13392. Now we need to do sig figs. Conversion factors don't count. There are 3 in my beginning number because there's a decimal, significant digit, so those zeros are significant. So 1, 2, 3, I look 1 to the right, so it becomes 0.134 moles of H2. The next problem, we're going to start with liters and we're going to go to moles, so we know it's molar volume. So this is going to be 1 mole of calcium chloride. And this is going to equal to 22.4 liters of calcium chloride. So we're going to start with what's given, which is 0.00130 liters calcium chloride. Liters calcium chloride, diagonals have to be the same, liters calcium chloride. So this is equal to 22.4 liters. That is the number in front of calcium chloride. On top, it is equal or equivalent to 1 mole. Diagonal units cancel out. We have the units we want, which is moles of calcium chloride. So 0.00130 times 1 divided by 22.4 liters will give you 5.80357. Now I need to do sig figs. Conversion factors don't count. I have 3 in my answer. These zeros are placeholders because there's decimal, no significant digit. This 0 is significant because there's a decimal and a significant digit, so there's 3. So 1, 2, 3, I look 1 to the right. The 0 stays, so it's 5.80 moles of calcium chloride. Pause the video, try these problems on your own, and then check your answer. Since we have moles and we're converting to volume, we know this is molar volume. So 1 mole strontium hydroxide is equal to 22.4 liters of strontium hydroxide. So we're going to start with what's given, 99 moles of strontium hydroxide. Diagonals have to cancel out, so this is moles. This has to be moles of strontium hydroxide. The number in front of moles is 1, so we put 1 here. This is equal to 22.4 liters, so 22.4 goes on top. Diagonal units cancel out, so we're going to multiply 99 times 22.4 divided by 1. That's 2,217.6. Now I need to do sig figs. Conversion factors don't count. There's 4 significant digits. These zeros are significant because there's a decimal and significant digit in front. So 1, 2, 3, 4, 1 to the right. So this becomes 2,218 liters of strontium hydroxide. In the last one too, it is molar volume because we have moles to volume. Remember, everything in this chapter will be at STP. So we know 1 mole of chlorine gas is equal to 22.4 liter chlorine gas. We're going to start with what's given, 1.30 times 10 to the negative 3 moles of chlorine gas. Diagonals have to cancel out. Moles of chlorine gas, moles of chlorine gas. 1 is the number in front of it. This is equivalent or equal to 22.4 liters of Cl2. Diagonals cancel out, and it's the units that you want, which is liters. So 1.3 times 10 to the negative third times 22.4 divided by 1 will give you 0.02912. So now we do significant digits, dimensional analysis, conversion factors don't count. Scientific notation, the exponent doesn't count. Everything in front counts, so there's 3. We start at the left, go to the first non-zero digit, which is a 2. So 1, 2, 3, I look 1 to the right. I need to put the 0 in front of the 2 as a placeholder. So my answer is 0.0291 liters of Cl2. So we learned 3 conversion factors. First one is molar mass, which is 1 mole X is equal to mass in grams X. It is off the periodic table. Avogadro's number is 1 mole of X is equal to 6.022 times 10 to the 23rd units of X. Units could be atoms, molecules, ions, particles, or formula units. Molar volume is 1 mole of X at 22.4 liters of X. STP is at standard temperature of 0 degrees Celsius, standard pressure, which is 1 atm, 760 millimeters of mercury, or 760 torrs, or 101.325 kilopascal. These conversion factors are always 1 mole of X, and we go to the same X. So if you notice, everything starts with 1 mole. The element or compound is the same before and after. Avogadro number starts with 1 mole. Element or compound is the same before and after. Molar volume starts with 1 mole. Element or compound is the same before and after. If you memorize these three conversion factors, stoichiometry is just like dimensional analysis. So these are mixed problems. You're going to use the 3 conversion factors to convert from one unit to another. So let's look at this first problem. It says how many molecules are there in 2.3 grams of ammonium sulfite? So gram, I know, is mass, and molecules is Avogadro. So we know we have to use 2 conversion factor. We have to go through moles. So that means we have to use molar mass, which is 1 mole of X. Here is ammonium sulfite is equal to its mass in grams of ammonium sulfite. And then we also know I have to do Avogadros because of molecules. So 1 mole of NH4 2SO3 is equal to 6.022 times 10 to the 23rd molecules of NH4 2SO3. I'm going to start with what's given, which is 2.3 grams of ammonium sulfite. Diagonal units have to be the same, so if this is grams, this is also grams of ammonium sulfite. We know the grams we must get from the periodic table. This is equal to 1 mole of ammonium sulfite. So I'm going to find the molar mass of this. So there is 2 nitrogens, because there's a 1 here, 1 times 2. There are 8 hydrogens, 1 sulfur, and 3 oxygen. Each nitrogen is 14.01 on the periodic table. 8 hydrogen, each of them is 1.01 gram. Sulfur is 32.07 grams. And each oxygen, there's 3 of them, 16.00 gram. If you do all the math correctly, you should get around 116.17 grams per mole. So the molar mass here is going to be 116.17 grams per 1 mole. The grams cancel out. If I stop here, I am at moles. I don't want moles, I need molecules. Do diagonals must be the same. So this is moles. This has to be moles of ammonium sulfite. Number in front of moles is 1. This is equal to Avogadro's number that goes on top of ammonium sulfite. So we're going to multiply 2.3 times 1 times Avogadro's number divided by 116.17 times 1. You should get 1.19227 times 10 to the 22nd. Now we need to do sig figs. Conversion factors don't count. Conversion factors don't count. So there's 2 at the beginning, so it's 1, 2. I look 1 to the right. The 1 goes up to a 2 times 10 to the 22nd units of molecules of ammonium sulfite. Try the next problem on your own and then check your answer. So here we have grams, and then we have formula units. So formula units we know is Avogadro's number. Grams we know is molar mass because that is mass. So we're going to use molar mass, which is 1 mole of N2I6. This is equal to its mass in grams. So we have 2 nitrogens, 6 iodines. So that's 2 times 14.01 grams. Iodine, there's 6 of them, is 126.90 grams. If you do the math correctly, you get 789.42. So the molar mass is 789.42 grams of N2I6. So Avogadro's is going to be 1 mole of dinitrogen hexaiodide. This is going to equal to 6.022 times 10 to the 23rd formula units of N2I6. So I'm going to start with the given. The given is 3.3 times 10 to the 23rd formula units of N2I2. Diagnose. Formula units. You need to write the units as well as the element. Formula units, the number in front is Avogadro, so that's 6.022 times 10 to the 23rd. On top, it's going to be 1 mole because they're equivalent. They're equal to each other. Formula units cancel out. Diagonal units, again, because if we end here, we are at moles, and we don't want moles. We want mass, which is grams of N2I6, 1 mole. All the conversion factors that we did all have 1 mole. This is equal to 789.42 grams of N2I6. So we're going to multiply 3.3 times 10 to the 23rd times 789.42 grams divided by 6.022 times 10 to the 23rd. And when you do that, 432.595. We need to do sig figs. Conversion factors don't count right here. So first number is a scientific notation. Exponents don't count, so there's 2 digits. So 1, 2 to the 1 to the right. So it's 430. You have to place the 0 as a placeholder. And this is grams of N2I2. Pause the video, try these on your own, and then check your answer. We want the volume of a 9.34 grams lithium chloride. Since we are talking about volume, this is molar volume. Molar volume says 1 mole of X, which is lithium chloride, is equal to 22.4 liters of lithium chloride. Since we have grams, we know we're talking about molar mass, which tells you 1 mole of lithium chloride is equal to its mass in grams of lithium chloride. So we have 1 lithium. 1 lithium is 6.94 grams. We have 1 chlorine, which is 35.45 grams. If I add this is 42.39 grams. So we're going to start with what's given, which is 9.34. Start with what's given, which is 9.34 grams of lithium chloride. Diagonal units have to cancel out, so grams of lithium chloride, grams of lithium chloride. The grams that we calculated here is 42.39. So that's the number in front of grams right here. This is equal to 1 mole because they're equivalent. The grams cancel out. But if we stop here, we are at moles, so I need to continue on. Moles of lithium chloride. Moles of lithium chloride. There's 1 mole of lithium chloride. This is equal to 22.4 liters of lithium chloride. The moles cancel out, and we have the units that we want, liters. So 9.34 times 1 times 22.4 divided by 42.39 times 1. This equals 4.9355 liters. So now we do sig figs. Conversion factors don't count. There's 3 in the initial number, so I need 3 in my final answer. 1, 2, 3. I look 1 to the right. The 3 rounds up, so it's 4.94 liters of lithium chloride. The next problem, we have grams to molecules. So we need to go to moles. So to convert grams to moles, we need to use molar mass. So that's 1 mole of carbon tetrachloride This is a covalent bond because carbon is a nonmetal, so the prefixes become subscripts. It's equal to its mass in grams of the periodic table. So there is 1 carbon and there's 4 chlorines. Each carbon is 12.01 gram. There's 4 times 35.45 grams for each chlorine. It adds up to 153.81 gram. So the molar mass of 1 mole of carbon tetrachloride is 153.81 grams. Since we need molecules, we know we're going to use Avogadro's. That is 1 mole CCl4 is equal to 6.022 times 10 to the 23rd molecules of CCl4. We're going to start with what's given, which is 200 grams. So 200 grams of CCl4. Diagonal units have to cancel out, so grams of CCl4, grams of CCl4, the grams in front, the number in front is 153.81. This is equal to 1 mole of CCl4. Diagonal units cancel out. If we stop here, we are at moles, so we need to go again. Moles, diagonal units have to cancel out. Moles, CCl4. There's 1 mole. We're going to go to molecules, Avogadro's, because they're equivalent. Molecules of CCl4. Do not abbreviate molecules as MOL. That's incorrect. That's the abbreviation for moles. So we're going to multiply 200 times 1 times 6.022 times 10 to the 23rd divided by 153.81 times 1. That's going to equal to 7.83 times 10 to the 23rd molecules of CCl4. We need to do sig figs. Conversion factors do not count. There's 1 sig fig because these zeros are trailing zeros. So 1, I like 1 to the right, it goes up, so it's 8 times 10 to the 23rd molecules of CCl4. In order to convert from one unit to another, we must always go through mole. For molar mass, Avogadro's, and molar volume, it is always equal to 1 mole. The compound element before and after must be the same. Final thought, do not abbreviate molecules as MOL. MOL stands for moles.